Hello dear students, welcome to Pen and Paper Chemistry on YouTube. Preparation and properties of aldehydes and ketones, part 4. Are you all ready with your pen and notebook? And of course, the favorite flowchart. Now using this flowchart, we've already covered the preparation from the left hand side of the compounds, that is alkenes, alkynes and alcohols. Today we are going to move across to acid chloride, preparation from acid chloride, nitriles and maybe esters. So we should be able to complete the preparation. So what do we have to do next is we have to pick up this flowchart and keep it at the right so that we can refer to it easily. Acid chloride are nothing but derivatives from carboxylic acids R C double bond O OH. You replace the OH by a halogen and you get what we call as an acid chloride in the common system. So RCOCl. Now what do I want to do? I want to get rid of this Cl and either introduce an H or an alkyl group in order to get an aldehyde or a ketone. Now introducing an H means I basically need to do reduction, right? But at the same time I have to be careful that I don't want to reduce the carbonyl group. That means I am bringing about a reduction in a controlled manner. And how do I do that? We do that with the help of palladium and barium sulfate as catalyst, but they have sulfur or quinoline as the poisons here. So that means we add sulfur or quinoline, and what do? Is they reduce the reducing capacity of hydrogen and palladium and barium sulfate combination, and that is why we will write over here as poisons, and this is known as Lindlar catalyst. Do you remember? We've spoken about this earlier as well. So go ahead, write the products of the reaction. So you will have RCHO plus HCl, right? Do you think I can prepare HCHO by this method? Meaning to say, I will have to start with something like HCOCl. Now this HCOCl is not a stable compound, and that is why in the mind map you will see that I have written HCHO and a strike off or indicated that this cannot be prepared by what we call as the, what do we call this reaction as? Yes, it is called as the Rosenmund reaction. It's a name reaction, and if you are studying this topic from examination point of view, this is an important reaction which you are asked. Now how about ketones? So ketones, that means I want to introduce an additional alkyl group. So what do is we've modified this and we've got RCOCl, and we react that RCOCl with dialkyl cadmium. Now go ahead, write the products of the reaction. Now in order to make it simple to recall and remember, again I'm going to resort to what I call as the boxes. Okay, what I have done over here is I've simply expanded and I have taken 2 molecules of the acid chloride. Now go ahead, you have the triangle over here, CdCl2, and we will form the products RCOCH3, that is 2 molecules of this. How 2 molecules? RCOCH3 plus CdCl2. Easy, right? Okay, now if I ask you to prepare CH3, CHO from its respective acid chloride. What acid chloride will you take? And I am asking you to prepare CH3COCH3. Now what will be your starting compound? Please go ahead, pause the video, try writing this reaction yourself. Have you written? Okay, let's tally our answers. CH3COCl plus hydrogen in the presence of Lindlar's catalyst gives us CH3CHO plus HCl. Now, interestingly, it's the same starting reagent, same starting reactant. So, CH3COCl, but when treated with dialkyl cadmium in the presence of a dry ether as a solvent. Yes, we did not write dry ether above. So, dry ether as a solvent gives us CH3COCH3, that is propan-2-one and cadmium chloride. So, you notice over here that we have the same starting compound, but we can prepare two different compounds from it. Did you manage to get it right? If you did, then please post 2 stars in the comment section. The next method of preparation is from nitrile. So if you see, we've further categorized it into 3 parts. Stephan reaction, which involves reduction with tin chloride and HCl gas, followed by acidic hydrolysis. So remember, there are 2 steps in this reaction. The other is again reduction with diol followed by hydrolysis, right? So let's go ahead and write the reactions for them. When we prepare aldehydes with using Stephan reaction, so the first step involves the conversion of the nitrile to an imine by the method of reduction. The reducing agents SnCl to HCl. So again, we will break it down here. The bond breaks H and H. What do we get now? RCH double bond NH. This class of compounds is known as imines. Then we carry out hydrolysis in an acidic medium. That means H3O positive. Hydrolysis. That means there is addition of water and there is breaking down as well. How do I remember it in an easy way? Break it down, O and H2. Simple, right? So let's get, no, this is not the mechanism. These are easy ways to remember how to write a reaction. Right, so here we've got the aldehyde. So supposing you want the end product to be CH3CHO, what will be the starting compound? And please go ahead and write the reaction. Pause the video, try it yourself. Yes, that's the answer to all the doubts. So those students who feel that is there any other way to remember organic chemistry other than the flowchart method? This is the only way. Pen and paper. You have to write down the reactions in order to be able to remember them, in order to be able to recall them when you want to write them again. That is for your examinations or for your class test or for your further studies. Yes, I have completed the reaction, but I have not yet written the reaction conditions. Please go ahead and fill in the blanks here. Now if you see over here, we are not adding an alkyl group and it's a little difficult to add alkyl groups to the nitrogen, to the nitrile. So we can only prepare aldehydes by this method. We can also carry out this reduction in a very controlled manner by using diol H, that is D for di, I for iso, B for butyl, Al for aluminium, H for hydride, diol hydride, that is di, isobutyl aluminium hydride. Compared to lithium aluminium hydride, this is a milder reducing agent Otherwise, our nitrile will have a tendency to be oxidized further. That is why, reduced further, and it will get converted into an alcohol. So what we do is, we use a milder reducing agent, that is dibyl hydride, followed again by acidic hydrolysis. Now you know the steps. Why don't you complete this reaction? Why don't you write the products? Yes, again, we will have RCHO plus NH3, right? Dibyl, diisobutyl aluminium hydride. Now, for your grade 12 level, you're just supposed to know dibyl, but if you want to break it down and understand a little bit more about it, let's go step by step. So our butyl is actually CH3, CH2, 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 right? This is butyl. Isobutyl. Now, if you've seen the videos wherein I have shared the breakdown of primary, secondary, tertiary, iso, neo, you will remember that this has a V over here, and we have CH2, CH3, CH3 and RCH. This becomes isobutane, right? Isobutyl here now. Now this isobutyl further combined with, we've got diisobutyl. That means we've got two of these diisobutyl aluminium. So that means I am going to combine this with aluminium hydride. Now, do you think I'm forgetting something in this structure? Yes, see, this is the free valency which is connected with aluminium. So that gives us dibyl hydride. Simply put, you can also indicate it like this: aluminium. This is one isobutyl, and yes, the bond line notation. This is the second isobutyl, and don't forget the H, right? But I repeat, this is not necessary if you are doing for your grade 12 examination, just focusing on that. Don't take too much tension about it. This is just to help you understand things in an easy way. Simply put, if you see over here, hydrogen, lithium aluminium hydride, 4 hydrogen, whereas here there's a single hydrogen. So you understand the limitation of dibyl as a reducing agent. It's a milder one, correct? So you can use it to reduce amides, aldehydes, ketones, nitriles, esters, etc. Got it? What is your job now? Yes, to write the reaction starting with CH3CN, or maybe why don't you try preparing CH3, CH2, CHO this time. Go ahead, write what will be your starting reagent for preparing propanol. Right? Did I get the name right? 1, 2, 3. 3 carbon atoms. So propane, propanol. Right? Al, not OL. So I have over here, I can also write it as a skeletal equation. So we'll have CH3, CH2, C triple bond N as our starting compound. Step 1 is reduction. Step 2 is acidic hydrolysis. Preparing aldehydes and ketones from nitriles but using the Grignard's reagent. Now Grignard's reagent, if you remember, we have done a complete set of videos on Grignard's reagent and how they are very useful synthetically. I would sincerely advise you to go through that video, because in your curriculum they may not have mentioned Grignard's reagent separately, but in each and every chapter you will come across Grignard's reagent. Each and every compound you will be either Grignard's reagent will be reacting with it, or you will be forming that particular compound using Grignard's reagent. So in your best interest, please go through that video. Just to have a quick brush up of what we have already covered in that topic. So Grignard's reagent are alkyl magnesium halides, bring about reaction with nitrile. So what we had done was that we had broken it down. Remember, the negative, the positive, the negative, right? The negative gets attached to the positive to the negative. HC, and this was, as I had told you, easy way of writing the reactions. I am not teaching the mechanisms over here, right? And the next step was acidic hydrolysis. That means hydrolysis in an acidic medium. What did we do? We broke it down here, OH and H, and we had broken it down over here, O and H2. What did we get? Look at the products carefully. So you have RCHO plus ammonia plus MgXOH. That is basic magnesium halide. We have got an R over here. There's no H. I started with the most basic nitrile. So HCN, hydrogen cyanide. Still, I am getting an aldehyde with an alkyl group. In other words, by this method, HCHO, methanol or formaldehyde, cannot be prepared by this method. But yes, we can prepare the other aldehydes using HC triple bond N by simply altering the alkyl group in the Grignard's reagent. So now go ahead and try forming CH3CHO from Grignard's reagent. So I will mark it like this. What will be here? What will be the Grignard's reagent? And of course, as I already told you, HCN reacting with Grignard's reagent gives you aldehydes always, and that is what has been written indicated in the flow chart as well. Are you writing? And if I replace the hydrogen by an alkyl group, CH3CN plus Grignard's reagent followed by acidic hydrolysis, I get a ketone, right? So go ahead and write the products of that reaction as well. If you are not confident, in your best interest, please revise Grignard's reagent topic. The last method of preparation is from esters, and as we spoke in the earlier set of reactions wherein we reduced nitriles, we said dibyl hydride is a very good reducing agent for esters as well. So let's break it down. But notice, remember, in both the reactions earlier as well as this one, we will keep the temperature low and we will keep the ratio of the reactant to the reducing agent as 1:1 because we want to keep the reaction under control. We don't want it to make an attempt to convert the aldehyde formed further to alcohol, right? So just break it down here, H and H. I repeat, this is not the mechanism, but this is an easy way to remember how to write the reaction. So go ahead, CH3, C double bond O, O, C2, H5. Reduction with dibyl hydride, minus 78 degrees Celsius. You can write the temperature in Kelvin as well. That is 195 Kelvin, is it? Let me know if my calculation is correct or not. Go ahead. Now break it down, form the product. What do you get? Yes, of course, CH3, CHO plus C2, H5, OH. With this, we come to the end of the preparation of aldehydes and ketones that I can think of. The preparations do not end at this. There can be many other preparations, but for the grades, for the level that I am aiming for, I think we've managed to complete most of the preparations here in this flowchart. Further on, we shall be dealing with the properties of aldehydes and ketones. Again, we will take them together because if you notice, they both have the functional group C double bond O. So a lot of their properties are in common, and we will end up doing 2 topics in one go. In the meantime, what do you have to do? You have to prepare the physical properties of aldehydes and ketones, and what you can do is you can do it as a comparative chart. So do it like this: aldehydes and ketones, draw a line, one side write the physical properties, so not the physical properties, so you can write the state, the color, that means whether they exist as solids, liquids or gases, or if they have any specific odor associated with them, the boiling point, melting point, and the variation both for aldehydes and ketones, solubility. So such points you can write parallelly in 2 columns, and your physical properties of aldehydes and ketones are also taken care of. No pains, no gains. Unless you start working on your own and start picking up your own pen to write the reactions, you will keep hopping from one video to the other. That's the whole mantra of learning organic chemistry. So please don't forget the pen and paper. See you in the next video. Take good care of yourself. Stay relaxed and stay happy.